All right, so we're going to keep going with the Clean Water Act today, moving from the jurisdictional questions we've been wrestling with, what's covered by the Clean Water Act, to what happens when more people are showing up. It's good. I'm just glad you're here. I'm not even care that you're late. At least you came. Yes. So we're talking about what happens when you're definitely covered by the Clean Water Act. We may, depending on how long it takes to get through things today, move up some of the reading. We only have 11 pages assigned for Monday, so we might just bump up all the reading for that next day to Monday. Also, we'll see. I'll let you know at the end of class. If this takes longer, then it'll take longer. We won't worry about it. But if we free up a day, then we'll do some work on actually looking at permits for some facility for Clean Water Act and for Clean Air Act. So it might be nice to actually deal with what this looks like on the ground a little bit. All right, so Clean Water Act, as we discussed kind of at the beginning of the Clean Water Act conversation, there's three main components. Funding for these publicly owned treatment works, the fact that you cannot discharge without the permit, and those different kinds of permits we talked about a little bit, the NPDES permits for pollutants, and then for 404, the dredge and fill permits for dredge material or fill material, which are also pollutants, but we treat them separately under a different permit generally issued by the Corps of Engineers. And the other part of this is the state water quality standards and the required water quality monitoring. And so today we're going to try and knit kind of all of these different things together to show you how it all plays out. This kind of parallels the Clean Air Act in a lot of ways, so as we go through, you should see some similarities to that. So there are three broad categories of pollutants. There's toxic pollutants, 126 chemicals that were specified in the Clean Water Act itself. The EPA can add additional pollutants through a rulemaking if they decide to regulate additional toxic pollutants. There's conventional pollutants. These are kind of like the criteria pollutants that we see under the Clean Air Act. Most water bodies have one or two or three or all of these pollutants in some amount. Okay, so they're fairly common, not something that you would be surprised to find in any given waterway, and they come from a whole bunch of different sources. So those are the conventional pollutants, and then there's additional non-conventional pollutants that show up in way fewer streams, right? So these aren't nearly as common. Things like ammonia, different colors, rivers that turn orange with iron in them, the kind of rusting iron color you'll see sometimes. All those are non-conventional pollutants, not things we see terribly often. So this is again, the key part here is that discharge of any pollutant by any person is unlawful except in compliance with the act. Indirect dischargers, those again are the ones that discharge to a publicly owned treatment work. So this is basically anything that doesn't discharge directly to the water, to a river or a stream or a lake, is an indirect discharger. And they get special pre-treatment or secondary requirements. Those can be national or can be established by the local sewage authority. They don't need a NPDES permit. They don't need an NPDES permit. That permit, the National Pollutant Discharge Elimination System permit, is reserved for those folks who are discharging directly to a jurisdictional water, right, a water of the United States. And again, this is the National Pollutant Discharge Elimination System permit because the thought was we were going to eliminate all of these discharges. Hasn't happened, so we allow discharges under the Discharge Elimination System permit. Yeah?
So an indirect discharger is subject to more of a standard but not a permit?
Don't have to have a standard, but there's only certain things they're allowed to put into that water.
But do they have to have a permit to?
Don't need to have a permit.
Enforce?
I think it's essentially you find something showing up in your publicly owned treatment work that isn't supposed to be there, or that you're not able to treat, and then you have to trace it upstream and figure out.
Which is like a general violation of the statute?
Yeah, exactly. They don't have a specific permit for that.
Why would the water treatment facility spend the time and money to trace it?
Depends what it is. If it's really nasty stuff or it's coming up their ability to treat the water. I mean, they have a permit for that publicly owned treatment work, right? There's requirements about what they're allowed to emit. And so if they're going through their normal primary and secondary treatment, which we'll talk about today, but they've still got a whole bunch of some random pollutant in there, they're going to go upstream and figure out where that's coming from because it's going to require a whole lot more treatment than what they normally do. So they want to make sure to track that down. And they can actually, so there's national standards for what the pretreatment is and what level of pretreatment is required that everybody has to follow. Local folks besides the sewage authority can crank that up. And the local sewage authority is the only entity that can say, that can reduce that standard effect. In effect, let folks release more pollutants directly to the sewage authority without pre-treating it, because for whatever reason they're able to handle it. So if they say, oh, it turns out we can actually deal with this stuff that you want to put down the drain, we'll let you put that down the drain, they can do that, but nobody else can relax it below the national standard. Other questions on that one? Nope. Okay. So these NPDES permits are supposed to be reviewed every 5 years. That's in theory, as is typical for these things. That doesn't actually happen on the 5-year cycle. They do get reviewed occasionally, but nowhere near that often. And they only ratchet up, they never ratchet down. So they may get tighter over time, they never get looser. These generally are technology-based standards, a lot of what we see under the Clean Air Act. And it's gonna get even more similar when we get to the acronyms, which will look fairly similar, just because that makes it more fun. So there's a lot of these permits. Nationwide, we held steady at about 100,000 from 1972 when the Clean Water Act passed through 1992. In 1992, we see a huge jump in the number of permits and then these little stepwise increases since then. Those increases come from the Clean Water Act amendments in 1992 that made it clear legislatively and not just judicially that stormwater needs to be permitted, any release of stormwater. So the water that comes out of the sewer, like the storm sewer system in your city and goes into the river needs to be permitted too. And that's why we went from mostly industrial facilities, all of a sudden all the towns that have a stormwater system have to get that permitted too. We see a huge increase there. And these are all related to that. They're kind of a stepwise increase as smaller and smaller systems had to get a permit. Yeah. Oh, good question.
Well, I mean, the NPDES, like, there's this limit of what you can pollute, right?
Mm-hmm.
How do you determine that from a storm drain? Like, I mean,
It's not easy to do.
What's gonna go in that?
Yeah. So you've seen it's really tough. It's very similar to non-point source pollutants, which the Clean Water Act doesn't even try and limit. But things like motor oil recycling programs to try and keep people from just draining their car onto the side of the road. All the little stickers you see on the stormwater drains that say, drains directly to the bay or drains directly to the river, or it has a little picture of a salmon on it. So there's lots of efforts to do it. Generally, it's very hard to treat that stuff, but you can reroute it into wetland areas, constructed wetlands, where essentially the wetland itself is treating it before it flows out. So there are ways to reduce the amount of pollutants in there, but it's not an easy thing to do, for sure. And that's why they resisted so long having it in here. A couple of early court opinions said, yeah, you need this, and then finally legislature got on board with it in 1992. Other questions? Good? All right, so these permits can either be issued by the EPA or the state if the state has an implementation plan. Okay, so same kind of structure as we see under the Clean Air Act. If the state is authorized by the EPA, the state can administer the Clean Water Act and issue these NPDES permits. So they submit a packet to the EPA, letter from the governor, memorandum of agreement with the EPA, program description, statement of legal authority, which explains the underlying state laws and regulations that permit the permit program, right? Essentially spells out what laws the state's passed to create a state version of the Clean Water Act. And then all of that goes up to the EPA. EPA has a public review, comment period, public hearing, very similar to what we saw under the Clean Air Act. And then EPA can either approve or disapprove the permitting system for the state. And if the EPA says no, then the state has to keep doing it. Or if the state has a permitting plan but doesn't follow it, doesn't do a good enough job, then the EPA will step in and EPA will continue administering the plan. Unlike the Clean Air Act, there's a lot of different levels that a state can be approved for. Okay, so the 5 different degrees of state authority. There's a base NPDES permitting authority. Non-federal dischargers not in other categories are the only things covered there. You can get federal NPDES authority to cover the federal dischargers, general NPDES authority, municipal sewage sludge regulatory authority, that's the biosolids, and then the pretreatment requirements authority to cover indirect dischargers. And the states can pick out kind of whatever part of that they want to try and handle on their own, or they can move through it in stages. So if we look at, this is as of July 2015, what states are authorized for what. The blue states here are states that are fully authorized for everything, except the biosolids program. The states that are slanted extra fancy, those include a biosolids program. That generally means that sewage waste from sewage treatment plants, those biosolids, right, are biosolids, can be a field applied at some place, which takes a little bit more treatment, a little bit more work. See the partially authorized states, and then the states that are tan here are completely unauthorized. So to get an individual NIPDES permit, the emitter, the polluter, that doesn't sound as nice, does it? The discharger, the prospective discharger, the prospective permit holder, puts together a permit application coupled with a fact sheet spelling out the effluent limits, monitoring conditions, standard and special conditions, which are things that get added to the permit. That goes through a public notice and comment period to create an administrative record, and then the final permit's issued. So it's essentially a rulemaking process every single time one of these permits gets done. It's not a rulemaking, it's actually an adjudication, right? We're making that decision, but you have to keep that record and have public comment as part of that adjudication. So it's a pretty stringent process that the states or the EPA has to follow when they're issuing that permit. So the permits have a bunch of requirements under Section 402 of the Clean Water Act. They have to follow all of these standards, Section 301, 302, 306, 7, 8, and 403. And we're going to walk through each of these standards. I know you're excited about it. This first one, 301, the technology-based standards. This is the one that's kind of most similar to what we saw in the Clean Air Act. Okay? Level varies based on the kind of pollutant, the kind of the discharger, and whether or not it's a new source or an existing source. So it's a multi-factor trigger, a lot like we saw under the Clean Air Act. The difference here, or one of the differences at least, is that we're not talking about compliant and non-compliant areas. Okay, we're just talking about what the pollutant is, what kind of discharger we have. Is it a direct, an indirect, publicly on treatment work? And is it a new source or an existing source? Not whether the area is in compliance or not. We get to that through a different route in the Clean Water Act. And like most of the Clean Air Act standards, these are calculated, determined on an industry-wide basis, not by looking at the specific facility. So existing sources, we see the same kind of new source bias here that we see in the Clean Air Act. New sources are regulated much more stringently than existing sources. So starting with existing sources, existing toxic and existing non-conventional sources, that goes back to that first listing we had of different kinds of pollutants. So toxics or non-conventional pollutants, polluters, dischargers have to use the best available technology that's economically available. It's kind of a mouthful, abbreviated as BAT. Existing conventional dischargers use the best conventional pollutant control technology, BCT. And existing publicly owned treatment works use secondary treatment. And we'll talk about what secondary treatment is in a second. Yeah?
So only in the first one you consider the economic positions?
No, unfortunately not. That's the only one that has it in the name, but you still include it when you're looking at this one too. All right, so BAT standards. This is the performance associated with the best control and treatment measures that have been or are capable of being achieved. It doesn't have to be that exact control technology. It just has to achieve the same degree of control and treatment that the best available technology has achieved. EPA has to consider the cost of attainability here. You're not doing a cost and benefit analysis, but you still have to consider the cost. Is this something that's going to put any treatment facility out of business because it's so expensive? Okay, so that's part of the whether or not it's achievable. And here, again, we're only looking at end-of-pipe reductions. These are existing facilities, so we're not going to make them rejigger their whole process in order to reduce pollutants. We're only going to say, what can we stick on the end of the pipe so before the water flows out of the factory, we're reducing the amount of pollutants that come out of that. So you look at that, you figure out a level that they're going to have to hit. They can choose to hit it either by adding that technology on, or they could go in and rejigger the facility in a different way, so that they wouldn't have pollutants at all, or would achieve at least that level of cleanliness, right, of pollutant reductions. But they don't have to use that particular technology. Good? Okay. For existing conventional sources, the degree of that we have BCT, and that is defined as the degree of effluent reduction attainable through the application of best conventional pollutant control technology, including measures in practice after consideration of a two-part cost reasonableness test. So cost, again, factors into this. These aren't the most stringent standards, and we're only looking again at the end of pipe reductions, not at facility-wide changes in order to reduce emissions or reduce discharges. All right, questions on those? Good enough? Okay. So the publicly owned treatment works, treatment levels. The primary treatment is when the solids just settle out. How many of you have been to a sewage treatment plant? Look at that, that's pretty good. All right. Yeah, it's a pretty special place. Huh? It all comes out in the end. So primary treatment, simple settling out of the solids contained in the sewage. A lot of times they'll treat it with something that knocks a lot of those contaminants, the solids, out of the sewage. Secondary treatment is what's required for existing publicly owned treatment works, and that gets rid of really the worst stuff. You can get tertiary treatment. This is the kind of best standard you ever see in these things. Full-blown chemical treatment of sewage to bring water quality back to clean levels. And that's extra verbiage, I'm not sure why it's on there. But essentially, after tertiary treatment, it's going to be cleaner than the river it came out of. You could drink water that's gone through tertiary treatment. If you hear about the toilet to tap kind of movements, which is a terrible name, but for a really good idea, we're using water that's gone through tertiary treatment in that scenario. So here's our depiction of a publicly owned treatment work. You get raw sewage coming in, essentially anything that gets flushed down a toilet, which is all kinds of amazing things beyond what you'd expect. And then there are screens there that will pick up the big chunks of stuff that's not biological in origin. So plastics, those little disposable flushable wipes that are supposed to disintegrate that don't really disintegrate, all get stuck all over. If you've been to those places, the people who work there will rail about how evil those are. The Hot Wheels cars, all of those things end up on the screen, and then the rest of the material goes through into a grit chamber, and then a sedimentation tank, and the solids settle out in that sedimentation tank to create sludge. This is the bio-sludge that we were talking about earlier. A lot of that's pumped out into the digester. Some of it goes from the digester into the sludge drying beds, from whence it can either be hauled off to a landfill or taken and used for fertilizer on fields, for mine reclamation, for all kinds of stuff. But some of this really good active, it's like a sourdough starter. Like once you use it, the sourdough's all excited, it's really growing well. You can put some of that back in to create more starter. But this is, human poop instead of sourdough starter.
This is terrible.
It's the same idea.
It's like green, pretty much.
Yeah, it's good. It's amazing, but it's the same idea.
No.
Okay, well, kombucha. Yeah, it's the mother. That's even. Nobody likes kombucha. Right? We're good.
Trying to ruin sourdough.
Might as well be the same thing as kombucha.
So you put that stuff into the aeration tank, and then the aeration tank actually has air pumped into it, and since it's got both air coming in and that activated starter, the bacteria really go to town, just digest all of the stuff that's in there, and eventually, it makes it super sour, and that stuff settles out, and some of that is then, whatever settles out then is pumped down to the digester. At this point, that water can be discharged to surface water, rivers, lakes, wetlands. There's a disinfectant stage here, but it's not to the kind of tertiary standard. Yeah?
So if Los Angeles County goes forward with the toilet to tap program, would the waste treatment be responsible for bringing it back to use, or would the water district
So
be
there's,
responsible, or are they the water district?
I don't know a whole lot about their specific programs. If anybody else does, feel free to jump in. But you have to meet the Safe Drinking Water Act standards, and the water supplier is responsible for that. And so they'd get water that would come out of this facility. I think it's going to be fairly integrated in order to make sure that water is clean enough as it comes in. One of the big problems with this whole thing is that there's a whole lot of stuff that we all take, mostly medications of one kind or another. And a lot of those medications make it through this process largely unchanged. So birth control pills is a big one. A lot of antidepressants come through largely unchanged. So the stuff that comes out, yeah, it makes fish hormonally confused but pretty happy. But if we're going to use this for drinking water, like you have to put it through kind of an activated charcoal filter or something along those lines in order to remove all those pharmaceuticals from the water. When we have fish in the San Francisco Bay, you can go out and catch striped bass there that have both male and female gonads because they're getting these massive doses of hormones in the waters. So kind of a big deal in terms of dealing with that. And it's something that cities have to deal with when they're taking water out of these river systems in order to use it for drinking water. All right, yeah.
How much like non-water related like environmental damage is there caused by this? I mean, just the amount of chlorine alone that's necessary to do something like this, I can imagine is astronomical.
Yeah, I don't. A lot of the things. So this, and I think you asked something similar about like what do they do with the stuff we pull out when we're dealing with clean air. There's definitely some chasing of pollutants across media here. Chlorine breaks down fairly quickly, which is a good thing. That's one of the reasons we like bleach so much. It breaks down. The half-life is very short in the wild. That's why bleach is stored in the white bottles so that sunlight doesn't hit it and break it down into salts, basically. So the big issue here in terms of chasing pollutants is the sludge, this biosludge. How do you make sure that it doesn't have any kind of live bacteria in there? How do you make sure it's not going to make people sick? The ag lands that you're able to use it on can only be ag lands where you're not growing food for human consumption. You want to be careful with people going into those places after it's been applied. So that's I think the bigger issue we end up wrestling with here. Other questions? All right. So this is just a write-up of what we've already said. Yeah. So the primary treatment removes about 30% of biological oxygen demand, and secondary retreatment will end up taking out about 90% of biological oxygen demand. What is biological oxygen demand? Biological oxygen demand is a measure of how much organic material is in the water. This is one of the big ways we measure for pollutants. If you end up with a lot of fertilizer in the water, or a lot of organic material in the water, that tends to produce algal blooms and encourages bacterial growth. When those bacteria die, when that algae dies, the breakdown of those critters takes oxygen out of the water. They're getting digested by other bacteria, and those bacteria use oxygen to do that. And that takes oxygen out of the water and can result in essentially water with no oxygen in it. How many of you are familiar with the Mississippi River dead zone? Oh my goodness. Okay. This is.
We will not be finishing early.
There's still. This won't take long.
You actually have like a tail that wags. It's incredible.
All right. So Mississippi River drains the whole Corn Belt. Right. That's my home. All these states that pour tons and tons of nitrogen and phosphorus fertilizer all over their fields, and that water comes down and is discharged out of the Mississippi River. It goes out into the Gulf of Mexico. We get some algal blooms, algae dying off, bacteria eating those dead algae, using the nutrients, reducing the oxygen levels, and we end up with a huge dead zone in the Gulf of Mexico where this nutrient-rich water is dumping in. Dead zone meaning there's no oxygen left, so the fish can't survive there. The shrimps? I guess it's multiple species. So the shrimp can't survive there. The size varies based on the year, but we're talking like a big area, like the size of Rhode Island, essentially is dead. Let's see if I can find a bigger image. The red there is the dead zone. Yeah, you can see the algal blooms. And yeah, hypoxic means there's no air. There we go. So 2014, about 5,000 square miles impacted by that. Not a good spot to be a fish. And this is not uncommon. We see similar things in a lot of areas where these big rivers with a lot of nutrients discharge into the ocean. And so we measure those pollutants by measuring biological oxygen demand. You essentially take the water, put it in a bottle, and see how much oxygen gets used up over like a 24-hour period after you collect that water.
Is that the same thing that's going on in Lake Erie, where it's like all green and everybody's super concerned about it?
Yeah, same idea. The great thing in those lakes is that all the zebra mussels are cleaning out all of the nutrients from the water. So, I mean, aside from pushing all of the native species to extinction and all that stuff, they do at least reduce the biological oxygen demand. If you look downstream of the publicly owned treatment work on a river, so here's our facility, primary, secondary treatment, and then it's discharging into the water. A lot of this has been removed, so a lot of the biological oxygen demand has been removed, but there's still going to be enough nutrients coming in here. It's going to be organic matter, nitrogen, mostly nitrogen, sometimes these are phosphorus limited. So organic matter, nitrogen, and phosphorus all get dumped into the water. Biological oxygen demand, it's going to be high here, and then it'll drop over time as you move downstream or over space as you move downstream in the river, and it gets digested out. And the amount of oxygen in the river will start high, drop quickly, and then recover here. So this is that low oxygen zone. Mississippi River is so big and there's so much in the way of nutrients going into it that the biological oxygen demand just stays high until it finally gets out to the ocean where there's enough room for the kind of bloom to happen, and then we have that giant dead zone there. All right, everybody good on that? Cool. So we have advanced wastewater treatment. If you add more treatment steps, sand filters at the end, that'll take out a lot more of your organic matter. Carbon filters, chemical treatments, taking this water and putting it into a wetland where you can have this high biological oxygen demand, but have that in a controlled environment, have that in a wetland where it happens fairly quickly. There's plants that are growing to take out a lot of the organic matter, and then cleaner water will leave the wetland area. So lots of different ways you can use it. You can use this treated water after advanced wastewater treatment for irrigation, for your municipal uses. You'll see golf courses that say watered with reclaimed water. Reclaimed is post-sewage water. So it sounds much nicer when you say reclaimed water, though. A lot of roadside areas in California will say that. And you can continue treating it then, or send it back into your drinking water treatment, like you were asking about, in order to use that as a drinking water supply. So we have these standards. You can get variances from the standards that we've talked about. Under section 301, to get extra time, there's essentially two major categories of variances. First is the economic hardship variance. If for some reason there's some special aspect of your facility that makes it really hard for you to use those treatments, the technology-based treatments that everybody's supposed to be using, you can get a variance that can soften the industry standard for your particular source and let you emit dirtier or discharge dirtier water. The other one is fundamentally different factors. And when you apply, you have to tell the EPA there's something fundamentally different about the water that you have. It could be the age of your equipment, the age of the facility involved, the engineering aspects of the different control technologies that you have available to you, non-water quality environmental impacts. The administrator can then adjust your requirements as the administrator deems appropriate. So a lot of discretion there for the administrator to loosen the standards. All right. So that covers our technology-based effluents. We're going to skip over water quality-based ones for now, and then we'll circle back to those. You also have to comply with, so when I say you have to comply with, this is, again, what the Act requires for a discharge permit. Not all of these are going to apply in every category, right? If you're not a new source, the new source performance standards don't apply. If you're not discharging into the ocean discharge standards don't apply. But the section 402 just gives us a laundry list that says you have to comply with all of these things. Easy enough, I guess, to comply with the ocean discharge criteria if you're not discharging into the ocean. So new sources then. New source is defined as a new source. It's a little bit cleaner than what we see under the Clean Air Act. There's a good statutory definition. A new source is considered a new source if it's constructed at a site where there is no other source. Okay, so you're the first thing there. If it replaces the process or production equipment that caused the discharge of pollutants at an existing source. So if you're replacing existing equipment, or its processes are substantially independent of an existing source at the same site. So you're adding on something new at an existing site. Modified equipment counts as new if it meets both 2 and 3 there. Okay, and you can get into different tests and case law on that, but we're not going to do that. And new source performance standards are, the new source performance standard applies based on when the publication of proposed regulations were issued. Okay, so it's not when the standards were finalized. It doesn't mean, it means once you have a proposal out for what the new source standards are going to be, anybody who starts construction after those proposed standards are out are going to have to meet those standards. I lost some words there, but the idea is that you want to keep standards from trying to rush to get built and start discharging before a new standard goes into effect. Okay, so they're written in a way that'll capture that. All right, so the new source performance standards, which is exactly the same name that we use under the Clean Air Act, same acronym, NSPS, reflects the greatest degree of effluent reduction which the administrator determines to be achievable through the application of best available demonstrated control technology, BADT, which is also one of the acronyms we use for the Clean Air Act, via processes, operating methods, or other alternatives, including where practicable, a standard permitting no discharge of pollutants. So now this is the big difference. We're not just looking at the end of the pipe reductions. We're going to look at the process, operating methods, or other alternatives that you're using within your facility. Okay, so if you are a paper making company, we're not just going to say, what end of the pipe emission solutions are out there. What can we slap on to reduce your discharge at the end of the pipe? Instead, the EPA is going to look at the entire process of making paper and say, is there a way to do this that results in fewer pollutants in your discharge, or even no discharge of pollutants at all? So that tends to be a much tighter standard because you're looking at it in kind of a soup to nuts approach. Cost is not explicitly included here, but the EPA has decided to consider cost when determining what the BADT is. All right, questions on that? Cool. So these are some examples. You can find these all on the EPA website. So we're looking at cadmium and copper, and it gives a BAT and the new source performance standards for the direct dischargers. So there's a 1 day in terms of milligrams per liter, and then a 30-day average amount in milligrams per liter. So you can have occasional spikes versus your 30-day amount. You can see the difference here between, in this case, best available technology and the new source performance standards. So cadmium, 0.69 milligrams per liter. For the 1 day, 30 day is 0.26. For new sources, it's 0.11, so like a seventh of that amount, and then this is 0.07 milligrams per liter. So you get much tougher standards for those new sources. All right, questions on those? And then there's also indirect dischargers, so these are the pre-treatment standards. And on these, they're actually the same as the direct dischargers because the publicly owned treatment works aren't going to be treating for copper or cadmium. They're not trying to remove those pollutants. So if you're an indirect discharger, you have to get your amounts down to the same levels because it's essentially going to be going straight into the environment. Okay. So those are our new source performance standards. Next, toxic effluent standards and pre-treatment requirements. You have to use the best available technology, or not. What does it stand for? BAT. There we go. Best available technology that's economically available. So best available technology economically available. I'm just going to say BAT because that's a lot easier. All right, so for toxic effluent, you have to meet BAT, but the EPA can require additional discharge, additional tightening of the discharge allowances under Section 307, specific to these toxic effluents. The administrator can do them. The administrator does not have to do them. But if the administrator does decide to increase those standards under 307, they have to require an adequate margin of safety. That may mean they go all the way to zero. It may mean there's some things that we just don't want you to emit at all, and that you're just not going to be allowed to discharge. And these standards do not consider costs and benefits. So the EPA isn't required to regulate these things, but if the EPA chooses to regulate them, they have to allow an adequate margin of safety. They need not consider costs and benefits, and they can tighten it up to the point you're not allowed to release these pollutants at all. All right, questions on those? And then pre-treatment requirements for toxics. The EPA, this is what we were discussing kind of at the beginning of class. EPA sets pre-treatment standards as necessary to protect kind of the standard publicly owned treatment work from having any problems with it or from violating their own standards. If the publicly owned treatment work thinks it can handle those toxic pollutants because they use additional technology, because they use tertiary treatment, then they can drop those pre-treatment standards if they choose to. State and local governments can increase the pre-treatment standards, make them tighter, but they can't ever loosen those beyond what the federal government allows. All good? Here's the handy-dandy chart of NPDES permit requirements. This is in the book too, so you should have access to that. Do you all have access to the electronic copy of the book? No? Okay. Well, when I upload this, you can pull it off the slide if you want it. Maybe the only new books may have it, or they may have stopped it completely for the old edition.
It usually has like a sticker somewhere.
Yeah, it's usually
This one
like here.
The trade-off is, I guess, you're not paying like $300 for the book, so it's probably worth it not to have the.
I got them on that.
Really? Okay. Interesting. All right. So I'll put this up online so you'll have access to it. But that covers our toxic effluent standards. Then next step, all of these NPDES permits have to have reporting and monitoring requirements in them. So if you remember way back when we talked about the enforcement during the enforcement class, we talked about how under the Clean Water Act, a lot of times it's the discharger himself, herself, itself that has to monitor their emissions and then report if they have any violations of their own permit. So the whole thing here is self-monitoring and reporting. They gather samples, they pay for the sampling process. Federal requirements specify how that's done and how it gets reported. That's in the permit, but in the end, it's the facility that is responsible for doing that work itself. And that creates some potential problems, but the Act tries to address those, and we'll talk about that in a second. These are real-world costs of monitoring a couple different pollutants: biological oxygen demand, total suspended solids, fecal coliform, which is bacterial coliform, bacteria, essentially fecal bacteria, oil and grease, times per year you'd have to monitor, cost per monitoring, and then the total annual cost for those tests. So it's not tiny, but maybe not as bad as you might imagine the cost to be. Of course, if you have a bigger facility, if you're monitoring for more things, costs are going to go up, can go up quite a bit. So the way this works, right, the worry is that if these facilities are monitoring on their own, they might lie about it. They might just report what they want to report, make it look like they're meeting a permit even though they're not. They might not be monitoring as frequently as they should. They might not use the right tests. So these permits require daily monitoring reports or every other day monitoring reports, and those reports are public records. So one, we've got the public kind of involvement here. The public gets to see that data as it comes in. To make sure that data is good, to make sure that data is okay, the enforcing agency, either the state or the EPA or their contractor, can come in at any time without a warrant, without notice, to inspect these point sources, take samples, and essentially ground truth what's being reported to them already. That may be because they suspect for some reason this facility isn't doing what it's supposed to, it's had problems in the past, or concerned citizens will call in and say, hey, I think something's going on here. And the other part of this is that Sure, discharge without a permit is not okay. Exceeding your permit, both of those result in a violation of your NIFTI's permit. But there's a lot of non-effluent permit violations on top of this. These are the paper violations that we kind of discussed briefly. If you don't submit your required monitoring reports, if you falsify the monitoring or other data, or if you don't meet the construction schedule deadlines for publicly owned treatment works, but if you're not monitoring the way that your permit says that you're supposed to be monitoring, then you face the same punishment that you would face for having a violation of your permit because you exceeded your permit. Okay, so you don't really have a reason not to report it because the punishment's going to be the same either way you go with it. And if you knowingly make false material statements, representations, or certifications as part of your reporting, or if you tamper with your device, any of these things, those are criminal violations of the Clean Water Act. So big penalties, $10,000 imprisonment for not more than 2 years or both for each instance where that happens. So that can add up fairly quickly. That's federal time. So we've got a system hopefully to keep people from wanting to cheat, to get rid of that impetus to cheat or to misrepresent their data on this reporting. In terms of enforcing these permits, the state can enforce them directly, the EPA can enforce them, or the citizens, under the citizen suit provision, the Clean Water Act can enforce them. These are the ones we read about. The Clean Water Act was the act that was at issue in Laidlaw, which we'll have a presentation on next week, and also the act that was at issue in Gwaltney. So it has to be that ongoing violation, and you do have to send a 60-day notice letter of intent to sue before you file that suit. All right. Section 404, or 403 rather, gives ocean discharge criteria. These standards were promulgated in 1980 and haven't really been updated at all since then, so they're fairly old standards at this point. And actually, there's a lot of folks who do discharge directly into the ocean, especially here in California. We're too far in here in Sacramento, but someplace like San Francisco has a lot of dischargers that are discharging directly into the ocean there. Most cities that are on the coast will end up routing their discharge from their wastewater facilities directly out into the ocean and releasing their material out there. All right, that hits all the things except the water quality based effluent limitations. And so we're gonna loop back to that now. Under section 302, we have water quality standards. So we have, under the Clean Air Act, we have all these standards that will kick in areas that are out of attainment, right? Non-attainment areas have tougher standards that they have to meet. We have a similar thing, except we don't have nationwide standards under the Clean Water Act. Standards are all established by the states, and then there's a system if the states are not meeting the standards that they've established. There's ways to tighten up the permits on emitters within those particular water bodies. So our primary approach are those NPDES-based, technology-based standards that we just talked about. But these water quality standards are essentially the backup to that. So if we're not achieving the water quality standards via technology-based permitting system, those permits will be tightened up even more beyond what the technology requirements would be. So beyond BAT, beyond BADT, beyond secondary treatment, any of those things, you can get even tighter than that for a given source if the water body to which that source is discharging isn't meeting the standards that it's supposed to meet under the state water quality standards. Everybody have kind of a rough feel for how the whole thing fits together? Okay, let's work through these and then we'll kind of pick it back up after that. So the general approach to these water quality standards is that the state sets the standards and the EPA approves the standards that the state has picked. If the state doesn't set them, as we see for most of these things, the EPA will step in. So there's a series of steps that the state goes through. The first thing the state does is look at each water body within the state. This could be a lake, this can be a whole river, this can be a section of a river, this can be a stream that flows into a river. You can have a river that has different designated uses at different parts of that river. Okay, the state will break it up in different ways. But the state looks at a water body and decides what use that water body should support. Okay? It can be something like public water supply, which is going to be really high, is going to result in really high standards because you want that to be super clean. Protection and propagation of fish, shellfish, and wildlife, water-based recreation, including full body contact water-based recreation, and partial body contact. Don't get all the way in the water. Agricultural, industrial uses, cultural or spiritual uses. Fishable and swimmable is the base requirement. It's not required everywhere, but if nothing is done, if there's no reason to depart from it, that's the standard that every water body is supposed to meet. When deciding what these uses are, you can consider economic factors. You can have more than one use designated. You cannot prevent another state's downstream uses. So considering how many of our rivers cross state lines, you can't keep folks downstream of you from using the river in the particular way that they want to use. So you can't get it as dirty as you want if it's dirtier than what they want it to be. And any current uses have to be supported in the future. So if people are using this river to fish in already, to eat the fish coming out of this river, you can't say that propagation and protection of fish, shellfish, and wildlife is not going to be a use for that river. And you can't just say, we're going to use this river to transport waste. Right? That would be really easy. You wouldn't need to keep it clean for that. That's not an acceptable use. Okay, so the state goes out, public hearings, does all this work, figures out what the designated uses are going to be of the water bodies. There's no numbers associated with this. It's just what uses are we going to put this water to. All right, everybody good with that one? All right. Next step then is based on that use, the state figures out how clean that water has to be in order to support that use. So what's the water quality standard associated with that designated use? EPA has developed a whole set of these that states can just pick up and use. If you want the water to be fishable, swimmable, that means you have to have less than X amount of this particular pollutant. Right? The EPA designates all those things. States can go lower if they want, but they have to show a scientific rationale for it and have to provide the same degree of protection. Okay? So the easy thing to do is just take what the EPA does, but states may want to go lower than that for any number of reasons. You don't consider the costs at this point, which makes sense, right? You've got the use that you've already designated when you're supposed to consider the economic impacts. But once you've decided what the use is going to be, figuring out scientifically what level of clean water is required to support that use, that's very clearly a scientific decision, not an economic decision. Make sense to everybody? Okay. These can be narrative. They don't have to be numerical. So it gets kind of circular when you say clean enough that fish don't die in it or something like that as your narrative description. The numerical descriptions are much cleaner. It's X milligrams per liter or per gallon or parts per million, something along those lines. But narrative values are okay, and you'll see that in some of the things that we'll look at today when we check out these water quality standards. All right. So as I said, you can have one river system and designate different standards throughout the system, right? So you can have, think about our rivers out here in California. You may want to have the headwaters section, the parts of the river that are way upstream, cold water areas, support cold water fisheries, so trout and salmon spawning. That means really low sediment, that means really low nutrients, really low suspended solids. You can probably achieve that in these headwater areas. But the salmon aren't going to spawn farther down in the river, and so as you move downriver from those areas, you get into the farming and agricultural areas, you may have more restricted uses of that water because you expect it to be dirtier at that point, and that's going to give you different water quality standards in that area. Does that make sense? Okay. So as you move downstream, you're generally going to have kind of worse and worse water quality, just kind of naturally because you're putting more pollutants in. And so the state can decide to designate different uses for those different reaches. And if they do that, they'll have different water quality standards for each reach of the river. All right. So after the water quality standards are set based on those uses, standards, next step is what water bodies aren't meeting those standards. We call this water quality limited water bodies. And you come up with a whole list of those throughout the entire state. You put them on what's called the 303D list. And that 303D list is submitted to the EPA every 2 years by the state. So the state goes out, it checks the water quality. It's supposed to look at all of its water bodies, but it doesn't happen, right? Well, I've got another slide on that, but it's a really low percentage of the water bodies that actually get checked. But they're supposed to find out every 2 years what's not meeting the standards. ones that are believed to be threatened, ones that are likely to become impaired by the time the next list is out. So it's not just the ones that we know are violating it right now, but ones that may be violating it soon. There's about 42,000 listed water bodies nationwide. It would definitely be higher if we listed everything, and not every state keeps up with this. 2 years to develop a report on the water quality for every single water in your state. Unless you're a state like Nevada that just doesn't have water, right? It's a hard thing to do. And Nevada doesn't have much money, so I guess it's a trade-off. All right. For the water bodies that aren't on this list, just like you see under the Clean Air Act, there are anti-degradation requirements. We can't make these things dirtier than they already are, or not much dirtier. And just like we saw in the Clean Air Act, there's different tiers. So tier 3, special water, something like a national park, it's gonna be clean and we're not gonna let it degrade, we're gonna keep it really clean. Tier 2 is the next lowest level, and tier 1 is still above the water quality standards, but not as good as the tier 2, the kind of standard water quality that we expect in most of the waters. And it's the same setup, right, as under the Clean Air Act. There's a high level for national parks, special areas. There's a mid-level that everybody's supposed to meet, and then you can drop down to a tier 1 to a lower level if you justify why this particular water body needs to have a lower standard. Yeah?
I'm sorry, when did we use this?
These are the anti-degradation policies. So this is water bodies that meet the standards, and it keeps them from getting worse. Just like in, Tahoe. Just like in attainment areas under the Clean Air Act, we want to keep those attainment areas from getting worse, and so we have special programs to keep those areas clean. And the basic rule here is that you shouldn't lose existing water quality, or existing water uses. And so you can get dirtier as long as you stay above the standard for your existing water quality use, or water uses rather. All right, all good? So getting back to the permits then, under section 301, these the effluent limitations in the permits, which are set initially based on technology, can get ratcheted down in order to keep water in compliance or to bring water into compliance. So if you have, the state designates the use, from the use you get a water quality standard, you develop a list of the water bodies that don't meet that standard, and then for water bodies on that list, you can change the permits for all of the permit holders, all the dischargers on that water body, in order to bring that water body into, essentially, we'd call it attainment under the Clean Air Act, but to make it so that it achieves the uses that the state designated in the first place. Everybody okay? Mostly fitting together? The way we do that is by establishing a total maximum daily load, a TMDL. And for each pollutant, any pollutant that you're not in attainment for, you figure out basically what amount of that pollutant can come into the water body in order to keep, and still keep that water body within attainment. So keep that water body under the water quality standard. So you look at a river and you say, hey, we can put 8 tons of nitrogen into this river per day, because it's a daily, so it must be a big river, I guess, to handle. Let's say a ton. 1 ton of nitrogen that can come in, you look at all the sources of nitrogen on that river and you break up that 1 ton of nitrogen among those sources, and everybody's gonna have to reduce their nitrogen emissions down to that amount in order to achieve the water quality standards on that river. Okay so far? Okay. And these states, so states develop your 303D list of impaired water bodies, and then a 305B list that includes all the water bodies that get monitored. This 303D list is supposed to include all of the TMDLs, so the state's supposed to develop those for every single impaired body. Some states have done this for all of their water bodies. California has not. California is definitely behind. We'll pull up a list of impaired waters in California here pretty shortly and take a look. And you'll see there's a group of them that don't have TMDLs and a group of them that do. So again, most water bodies aren't checked on a yearly basis, or even on a every 5 years or every 10 years basis. But these 303 lists are published for all the states, and at least lets us know what's definitely impaired. So these are all of the watersheds. They're identified by an 8-digit hydrologic code that the EPA issues for the watersheds. when we were playing around on the environmental justice mapper the other day, that mapper has a layer that you can use to turn on hydrologic codes, and you can see all of the lines for these things, and you can turn on impaired water bodies and see where the impaired waters are in a given area. So darker here means more of the waters in those areas are impaired. And gray is no waters listed, so Nevada, not a lot of water. All right, so let's take a look at the California list. We've got a long website to type in this time. You could probably Google it too. But find a water body near you. Find out if it's impaired or not. Assuming it is, we're in California, so it probably is. Figure out what it's impaired by, what pollutant it is, what the sources of the pollutant are, and whether or not there's a TMDL for that water body. And once you get that, chat with somebody else about it a little bit. I literally just went to this website, so this one should definitely work.
I blame Trump, man, it's not you.
I like that. For everything. Questions I can't answer. Trump's asking not to answer that question.
Failed your midterm, blame Trump.
Seriously?
No, it's fine. It's there. I got it.
Oh.
All right, try again. Maybe
Now
have this type something. There you go. Can you scroll down a little bit? There you go. So once you get to the page, if you scroll down to impaired water bodies, that's where the reports are.
Which one is it? So I'm sorry, we wanted the 2014, 2018?
2018, they're just gathering information.
So the 2014, 2016?
Yes.
Integrated. Do we want the final?
Sure.
So when the final staff report,
Yeah.
the draft,
I don't want that draft.
just do the draft report.
And there'll be hot links in this that'll take you to other documents with more data on particular rivers or particular watersheds. The appendices are where the actual lists are. Category 5 has no TMDLs. Category 4, some of those have TMDLs.
They don't do it by region or county.
No. There is a map once you link through to some of these. That'll show you where they are. So if you click on the hot link for the river, I think that'll take you to a map. Yeah. It's nice and circular, isn't it?
DDT.
Hmm.
Just kidding. There's more stuff to the right. It's not this.
Sorry.
There you go. Yeah.
Used to hang out.
Compton Creek.
Give the appendix.
Sure.
That's not in your.
No. Compton Creek. Yeah. Straight out.
Yeah.
How's Compton Creek doing?
It's kind of high in iron.
Oh,
Heads up.
Yeah, in the table.
Lots of lead.
just
It's not in the doc, yeah, it's like linked to it.
So if you go to the appendices, there's
So
an
go to,
actual
go
list
to
of
final
those.
staff report, but then, very
Are you just going through?
Yeah, click on one of those. It'll take you to a new page.
Who's a creek?
I just
And then
Okay,
category
Creek.
one,
So it gives you to walk into your water body name,
Which,
and
just
then,
command one through
it'll tell you
four.
what the water body is, and
Keys.
the pollutant is it's impairing. it. No, there's actually a map someplace. Let's see if I'll find the link to the map.
DDT.
You found a map.
Here's the map.
Where'd you get the map?
I just went to the Midwife site and searched impaired water bodies, like you said.
So if search for impaired water bodies on the website, the water board website, it'll take you to a spot where there's different tabs. You can click on one of the tabs, the map tab. I think that's from an older report,
Yeah,
but
that's from 2010.
yeah, it's from the 2010 report, but the presentation's really nice in the 2010 data, so you can use that if it's easier.
Oh, never mind. I don't know. You're on your way.
2010 integrated.
Basically, the folks that write this just write this, like that's all they do. You write one and you start gathering data for the next one and get it written. Yeah. Not a really okay. Click on the maps tab right there.
They're saying emojis there. Christopher, I have a question about emojis.
Right.
And when they say so, figure it out 100%.
Cause like we're going back in time.
When they say this is present,
Oh, yeah, that's what
but
Right.
they don't say in what form.
Yeah, and that data is available someplace.
But they don't put it in.
They don't have it in here yet.
And then what is this?
That's how much of that reach. So between those 2 points.
Mhm.
So it's probably
That's the distance of. I mean, figure out a road is probably the distance.
Probably the full amount. Yeah.
Okay.
Have they developed a TMDL for that? They're all fives. That's I think means no TMDL.
So now I go to this one.
No,
Oh,
so
that's 4B.
that's so yeah, you're in five. So we scroll down a little bit. At some point, I know it's like cover where five is. I think it means they don't have the
Do not list
the TMDL right before it says.
Scroll down.
But not in here.
Oh,
Sorry.
Oh, so I then just want to.
Oh, that's it.
How do I get rid of you?
I have to turn it off before I teach.
How do I do that?
All right, people find this stuff.
What are we looking for again?
Being addressed.
Local body of water, like near your hometown.
And you can use that map. So as I said, if you search for compared water bodies and then click on the map tab, it'll take you to a nice map that shows all the compared water bodies.
So does this mean they're
Oh, so
assessing
all,
the TMDL
everything
or
that's
it's-
purple is impaired?
Oh, no, you have to
You
put
did
no,
click
Five is
change
still
it.
required.
Yeah.
Copy the.
So they've made a TMDL, but it's being approved.
Yeah, exactly.
That's good.
It's something. And so you can actually find that TMDL for that water body. So if you search, LA River TMDLs,
But ultimately, it has to be swimmable and fishable.
generally that's the use that says it can. And I think the Los Angeles River is too.
I imagine it. I mean, if that's the, I mean,
That's the
shit,
goal.
that's the goal.
Yeah.
Am I missing the weight on the map?
You can see, it's still see, right?
Swim in that. Swim in that like every 4th of
Where'd you
July.
find Mercury?
Okay.
Five A says.
Oh, I don't know.
What about
Is it just
Willis
the one?
Slough bypass.
You guys found that
Equal
dam?
Everybody finding some
Equal
stuff?
flow.
Oh, and that's the stretch?
Yeah, it's 27 miles, yeah, so we go from Winters all the way through Davis. Where does the Cutter to the creek that's out?
It flows into,
Davis,
it
right?
goes, they used to go through Davis, they rerouted it. There's a Buda Creek in Davis, but it's not
Buda,
Buda
yeah.
Creek.
Told you.
It flows down into the delta and kind of confuses into the.
The sluice, right?
Yeah.
Okay, like Bear Island.
And then eventually, yeah, it's the, fixed it.
So really, you can fish there, they're just gonna be exposed to it.
Makes them twice as heavy.
Not a big deal. Yeah, exactly.
They pull harder, yeah.
Yeah.
Watch it work together.
They used to stock it, I think they stopped. I'm sure that might be like one of the reasons.
There's a nice, salmon run in there now.
Oh, is there really?
Interestingly enough, yeah, and so they stopped stocking it with all the non-native fish.
Yeah.
But if you go up to Winters.
That's where we used to catch like some rainbows, they'd stop
Yeah,
right there.
so the stills, there's a steelhead run in there, you could probably catch steelhead in that right below the Lake Solano dam.
Yeah.
But there's a big, like, 800 to 900 fish salmon run, that comes up in there.
I had no clue.
Winter Salmon Festival, and
Yeah, nice.
it's neat, they're doing some really good restoration work there, like rechannelize the river, keep it flowing.
Yeah.
Professor Burton, what happened is that you were telling me just like, you were telling me just
There's
south,
Mercury.
or just
Like snow.
on the Davis side of the Lake Solano Dam is a good
Mostly aluminum
Uh,
surrounding resources.
So you can fish, there's rainbow trout in Lake Solano, but above Lake
Still
Solano,
like a lot of mercury on some.
yeah, this whole stretch here is all between is
That's where
public.
it's at.
Yeah, and
This
there's,
is where, okay, this
there's
is
some
the
very
area you
smart
were
trout
describing
in
to
there.
me.
And then,
Do you know where the exit is?
He used Mercury like
there's not
exploration.
all
It's just
along there.
trails that go down.
There's something
And
else.
then the other one I was talking about
Is that
is,
various?
yeah, that's berries.
still there.
No, but it's always so busy, they need to expand.
Somewhere in here, I was trying to show you the
Oh, I
Oak
totally
Canyon.
forgot about that.
Yeah.
road.
I didn't
goes
know
all
that it
over.
did work.
Yeah.
No, I know that it did.
So up in here,
Oh, how's your parents' work?
this is all.
It made it.
That's good.
It's all, it's the cedar
Are there
rocks.
And the others,
Sort
and
of area.
This has water.
This has water.
they can, but there's no
And
gas.
you come up here, you cross this
I
creek,
guess
and
you
then you
like
hike up a little fire road, and then once you go up in here, it's, yeah, it's all,
Is this a road?
all wilderness.
Paper?
One of
Yep.
two cabins that left
And
behind.
then,
Oh, it's called Canyon Road or something?
yeah, exactly. And there's some trout actually in this, this stream through here.
They're like, negligible, they can swim.
They're-
Yeah, or it's
they're-
right there.
Oh, that's a way above
Because it-
Woodbury, isn't it?
It's,
Or,
yeah,
not
it's
way inside,
above.
but just at the top.
Supposedly there in Poudre Creek itself, where it comes out of the lake above, there's a historic steelhead run that still happens.
Oh, I didn't know that.
Yeah, the fish, the steelhead use the gray asa has in the ocean instead of going out to the ocean.
Oh, alright.
It's usually big, like 2 foot long steelhead, it's a tiny little creek.
Have you noticed all the birds at the
What?
Is that just migration?
It's the start of the fall migration. They also just flooded it, so they pull out their ice and then they flood it.
I was gonna ask you, when
Shoot.
did
Not to shoot.
Oh, I can tell you first one. Last week?
Yeah, 2 weeks ago. And the birds just descended wholesale on there.
Do they just do it at random times?
No, it's as soon as once the rice comes out, they open it up. You can see it like for a couple of days.
Oh, it's slow.
It does have a tree in
Yeah,
it,
it's,
and it
it's,
doesn't.
yeah, it's a pretty slow process. And then they'll open it. This is all one that they.
I couldn't find a key for the
Gradually, but if they,
Things
for
up.
flood control stuff, there's a weir that they'll open up way
Just
upstream.
kidding. Some of them,
And
I
that's
think
when
it's
you
just.
see like winter floods going on.
So during rainy season last year when it was, looked like it was 5-6 feet, that was because
There's
they opened up.
Oh yeah, all resource
they open up all the weirs up there. And then that's the salmon use that area is rearing
It's not all
habitat too.
resource.
It's a great spot for
tell
baby salmon.
my
They
PC
really like it. They grow like twice as fast there as they do in the river.
Unknown
You take a
toxicity.
kayak out on it?
You can. It's a big area. It's pretty
Mercury.
Sounds pretty fun.
I like from Carson by my works at the Watershed
I
Science
didn't
Center.
know what.
They were going out there last year when it was all
Oh, did they
flooded.
close it?
Yeah. They're going out flooding. They're going out like
Oh, yeah,
catching these little fish and
Chlordane,
water quality samples and all that when it was flooded. And he said there was one foggy day they went out there and just like,
That's by our house.
you know, 5 minutes from shore.
Pocket.
Completely lost.
It's huge.
No idea where anything is.
Should not
Felt
be
like an ocean.
show that.
So finally they figured out that they still had a cell signal. So they got their cell phone out and they're like,
Had to map it on the GPS.
yeah, cruising around, so Google Maps and the trolling motor.
You were saying that this one, just above the.
All right, everybody finding this info? Everybody doing okay? All right, so let's bring it back together here.
You think, I have, look at the South Dakota, and they're saying that there's mercury, you think that's from gold mine days?
Yeah, we have a pretty high background level of mercury here.
Middle Fork, we do, big time.
Yeah, but it's almost for sure related to the gold mining. So, good times.
That's why they have like the dredging stuff, right?
Oh, yeah,
Mixing up the mercury.
You mobilize it and then it goes downstream. And a lot of the stuff that's in the river isn't bioavailable yet. It's when it settles out in the wetlands and gets methylated and then gets picked up in the food chain. Yeah. Yeah, that sounds like mining to me. All right, any questions on this? Everybody good? All right. So our major, the top 4 reasons that water bodies don't meet the state water quality standards. Lakes tend to be nutrients, sediment, dissolved oxygen, then pH. Estuaries get a lot of pathogens in there. Fecal coliform, metals, that's mercury, that's for us. And then dissolved oxygen there. Streams and rivers, sediments, metals, pathogens, and nutrients. Metals again, mercury, we see iron sometimes. But for all these sediments, or at least these 2, sediments show up, nutrients show up for a couple of these, pathogens show up in a couple different places. Those are kind of the most common water quality problems that we see. So states can waive these water quality standards over parts of streams, so little sections within a reach of a stream that has a water quality standards. And they can do this in 2 cases. First are mixing zones. So these are the areas, like what we're looking at here. You've got the water coming out of a publicly owned treatment work. The biological oxygen demand is really high right where that water comes in. And then you have a mixing zone where the biological oxygen demand is dropping, oxygen levels drop, then come back up. This is the area where essentially this water that you're putting in is getting mixed into the stream water and then getting re-oxygenated after you've depleted some of that oxygen. Right, so this is a mixing zone. It's an area right next to a source, a discharger, and states can waive their water quality standards there. So maybe don't play like directly downstream of your publicly on treatment work. And during extreme flow conditions, usually during extremely low flow events, states can waive their water quality standards. This goes back to the old adage, the solution to pollution is dilution. When there's not enough water in the river to dilute the pollutants that you're putting in there, the state can waive the water quality standards to allow for undiluted pollutants to flow through the river. Everybody understand that? All good? Okay, so when you're developing this TMDL, remember the TMDL is how you get from waters that don't meet water quality standards to tighter permit requirements. You get an allowable pollutant load. So you look at this stream like we were talking about. Got a stream flowing through, and you say we can allow in 1 ton per day of nitrogen. And if we go more than that, then the stream is going to exceed the water quality standards for the uses that we've designated on that stream. Everybody good? That part makes sense? Then you have to add in a margin of safety. So if the river could actually only handle 1 ton, maybe you do 1.2, maybe you do 0.9 tons per day allowed. So maybe we think the river could actually handle 1.2, but we take part of that off in order to have a margin of safety in case we screw this up. And then you allocate that load among the different sources, the different potential sources of pollutants. And those different sources are natural background sources, non-point sources, that's called the load allocation. And then the point sources, that's the waste load allocation. Okay? This generally tends to be litigation driven when this is happening because states don't like to do it. So we've got this looks like a house. Now it's a factory. All right, some pollutants coming out here. Got a discharger. Got another discharger. Another discharger here. All putting in pollutants. We've got a farm here. And the farmer's fertilizing. Right, all over.
The best money. It's the best picture.
I feel pretty good about this one.
The photographer was how much achieving you're taking pictures today.
And then we've got here's some birds.
More pollutants.
They're pooping in the water. All right. So we have some level of nitrogen that would exist in this watershed without people. Right? That's our background amount, the natural background source, and that might be 1/3 of a ton. Right? So the river could handle 1 1/4 ton of nitrogen. We take out a 1/4 ton for the margin of safety, 1/3 of a ton for background. And then we have our load allocation, non-point sources. But do we regulate non-point sources under the Clean Water Act? No. That makes it hard when you have runoff from this field that's going to be waste, it's going to be load allocation, it's going to be a non-point source. We're not going to regulate that. So there's some amount coming in here. For nitrogen, that's probably going to be your main source because we put fertilizer on our fields because we like to eat. So we put on that nitrogen, a lot of that nitrogen runs off. So maybe we've got, we'll just call it 1/3 of a ton, but likely to be closer to 2/3 of a ton if we're actually looking at amounts. For load allocation, and that would leave us 1/3 of a ton for our waste load allocation, and that 1/3 of a ton has to be split up among these 3 different dischargers. Their permit may let them emit a whole lot more than that based on whether they're a new source or an existing source, right? And so you go back and look at which one of those, the BAT or the BADT, whatever it is, applies to them. But no matter what their permit originally says, once you've got that TMDL, the total amount that can come in for your waste load is going to be a much smaller amount. And that's, again, going to limit what they're able to put into the stream. good with that? And so that in effect tightens up the standards that they could otherwise do. And if all you have is sources like this, right? Sources that are golf courses or other big offenders, urban areas tend to put especially oils into the rivers. If all you have is load allocation, there may be nothing left for your waste load allocation. Create some interesting incentives where these folks are trying to get those folks to adopt best practices or some way to reduce the amount coming off their land. So once you get that TMDL done, once you figure out what you have for your waste load allocation, that's going to tighten up all the permits for that water body, and hopefully then bring you into compliance. Big problem though is about 40% of all impaired waters are impaired only because of non-point sources. And the Clean Water Act just doesn't reach those. We didn't think that was going to be the problem when we passed the Clean Water Act in 1972. The thought was like, we've got rivers catching on fire, right? That's not non-point sources that are driving that. And so that was really the focus. But it's emerged since then. We've grabbed all the low-hanging fruit. And this is the big problem. States can go after this if they want, and some states really do, but the feds don't.
Does California?
California does some. Yeah, California does better than most.
Is that why there's so many? It seems like there's more carrots than sticks in terms of rebates and like have efficient appliances. Because that's really the only way that they can effectively.
That's exactly. So we develop best management practices, and then we encourage people to adopt those. We pay farmers to fallow some land. We pay for having farmers create wetlands or leave wetlands on their land, because all those things reduce those non-point sources. It helps some, but it's a huge problem. We just don't have a good handle on it across the board.
And maybe you said this earlier and I just lost it, but do we have an idea of what the majority of these non-point sources are? Is it just individuals? Is that?
So the major, I don't know if I have a picture. This is just, again, saying that same thing. So non-point sources, there we go. Ag is the single biggest one. It's farm fields, it's sediment. Forestry is a big one in California because when you cut down trees and you get increased surface water runoff, increased sediment that comes along with that. And an awful lot of the water bodies in California, Oregon, and Washington have designated use for steelhead spawning, salmon spawning, and trout spawning. And if you get sediment coming off of logging roads, coming off of logged areas, that keeps those areas from being usable by those fish. And so that's the big non-point source pollutants there. Urban runoff is a big one. Golf courses, all these lawns we have, beautiful manicured lawns with all the fertilizer that we dump on those. I mean, the farmers at least have an incentive not to use too much fertilizer because it's expensive, right? They don't want to be putting extra stuff on beyond their kind of innate desire to protect the environment. They don't want to waste money on fertilizer that's just going to go away. But for a lot of us who buy, my yard looks brown, I'm going to put some fertilizer on it, right? Urban runoff becomes a pretty major issue in a lot of these areas. Golf courses, like I said, is another big one because we like to keep them so nice and pretty and green. But those are kind of your typical non-point source pollutants, or non-point sources. There we go. All right. Other questions on that? Yeah.
Not really to this, but have they made a connection to like fishing, lead, and I know a guy that like not dredge, but almost took 2 tons of lead out of a river here.
Wow.
And he just set up a scuba tank and literally pulled out over 2 tons of
That's
lead.
pretty amazing. I think the lead in that form tends to just sit there. Yeah, I mean, I think there's probably ways it gets mobilized, but the bigger concern, the reason they've started banning lead in some areas, the reason they've banned lead shot isn't a water pollution issue, it's birds eating that lead shot. Then they get the toxic effects of leads on the birds, which is not good for the people who eat them later on, not good for the birds, solve those problems. They dive down and they're always looking for stuff for their crop, for their gizzards to help crush things, and these little lead pellets are things they pick up to do that. But no, it's a good question, and I haven't seen anything drawing that connection yet, but I'm sure it's an issue in some places.
Like lead in the water. It's not good.
It's generally
As a
true.
fisherman, but-
Yeah, as I bite the split shot to put them on my line.
Yeah,
it's-
exactly.
I'm having a hard time reading this chart. So what this chart's saying is that the highest non-point source polluter is ag, or in that
not just non-point sources, the single biggest source of pollutant across all the different ways that you can pollute. For rivers and lakes is ag. Municipal point sources is next, and then the third, in-stream habitat changes, urban runoff, and then ag for the estuaries over there.
And a municipal point source, that's a,
Publicly owned treatment works,
so that's
generally.
That's not a non, okay.
Yeah, those are point sources. If it's municipally owned.
I know.
Yeah, so this is showing out of all the different sources of pollutant, non-point sources are the number one impairer for all of them. And for all of these, they're two of the top three sources. So we're just not capturing this part of it now. So again, virtually no power in the Clean Water Act. Farms written out of the Clean Water Act to a large degree. Ag, we talked about this earlier, ag irrigation returns not regulated, ag stormwater runoff, the runoff from the fields are not regulated. There are best management practices, things like leaving a buffer zone between your field and the water source, right? Not letting your cattle wade into the streams, fencing your cattle out of the water sources. All of those things are ways to reduce these impacts. California, land's so expensive. If you drive through a field, there's no buffer zone on the vast majority of fields you see out here. That plowed edge goes right up to the little drainage ditch that has the irrigation water on the side of the side of the stream. In a place like Kansas, where land is cheap, you have buffer zones. Part of that's part of the way that the land was settled there, but most folks there have 10, 20 yards of land between the edge of the field and the road. It's also because deer hide out there and quail hide out there, and so the farmer likes to have that to hunt later on. But we just don't see that here, and so you have more problems with runoff here than you would in a place like that. There are some efforts to address non-point sources. So Section 319 is the section of the Clean Water Act that does cover this, but it's not a hammer. It's like you said, it's a carrot. Right? We're trying to incentivize this action. Provides funds for states to develop non-point source pollution management programs. So they can create essentially funding for the states to do these things. States don't have to do this, but if they choose to do it, the feds will pay for that to happen. Right? So a lot of states have done that in order to get those 319 funds. And we'll read a case about this a little bit later on, about when you have to develop a TMDL and why, kind of how big a hammer or a carrot those 319 funds can be. All right, so here's the helpful diagram that kind of shows how this works. Set your water quality goals, set the goals for the uses. That gives you a water quality standard. You do your monitoring. And the question is, do you meet your water quality standard or not? If you do, great. You apply those anti-degradation standards and then just keep cycling through this on a 2-year basis. If you don't, then those water bodies are listed under the 303 impaired water bodies list. We call them impaired because the uses that they're designated for by the state are impaired. They aren't meeting those uses. Once you have that list, you develop strategies and controls. Part of that is the TMDL process. These are different other options, the NPDES permits, the 319. There's a couple other sections that we're not going to worry too much about. And then you go back and evaluate within that 2-year period, are you meeting the water quality standards? If not, stays in the 303D list. You may need to tighten up those TMDLs. You may have been wrong when you figured out how much total pollutant this water body could handle and still meet the water quality uses that you've designated for it. And you just kind of keep cycling through this loop until eventually you meet your standards, and then you apply your anti-degradation technologies or anti-degradation policies to it. Okay, everybody good with that? Questions?
What's the state revolving box?
Yeah, so it's another one of these grant kind of carrot programs. And there's a whole lot of them that we won't get into too much. So judicial review, the citizen suit provisions of the Clean Water Act. Under 509B, you can get judicial review for certain EPA actions. Promulgation of national effluent limitations, issuance of NPDES permits, and approval of state permit programs. You can challenge any one of those under Section 509B. Section 505 is your general citizen suit provision. You can sue anyone, right, any person for violation of their effluent limitation standards or any other permit conditions. Monitoring is the big one that people get nailed for there. You can sue the EPA for failing to perform non-discretionary standards. Usually that's promulgating regulations or promulgating them wrong. If you think the EPA hasn't done it correctly, you can sue them over that. You can't, unlike the Clean Air Act, you can't sue the EPA to force them to, or sorry, rather, unlike the Endangered Species Act, you can't sue the EPA to force them to go after violators. And that's the way most laws are, right? You can't sue the prosecutor for not filing a lawsuit, for not prosecuting somebody, because we want that prosecutorial discretion. So that's fairly normal. And then, as in most cases, you have to give a 60-day notice of intent before you file that lawsuit. If the feds or the states takes action, you can intervene as a matter of right after you've sent that notice letter, but you aren't going to be the lead in the lawsuit. The feds get that. And generally, the review of the permits issued under the state delegation is going to be in state court, unless somehow you're raising a federal argument under the Clean Water Act. The review for those permits starts in state court and not in federal court. Okay, questions about our citizen supervision judicial review here? All right, we're done 3 minutes early. Very exciting. So as I said, I warned you we might get done early, and if we did, I was going to move up readings. Or if we stayed on time, I'd move up readings. So today is the 18th. So for Monday, we're going to have both Monday's reading and Wednesday's reading, but we'll keep that presentation on Wednesday. So we're not going to move Laidlaw up. But Monday and Wednesday's reading, which means you'll have, 21 plus 11, 32 pages for Monday. So still not a bad assignment. And I think that's, we'll move up the next set of readings too, and that'll give us some time on Monday, October 30th, to do something a little bit different and actually dig into some permits. So that'll be the plan for Monday, October 30th. And those people who didn't make it today won't know that. So it'll be extra exciting and spicy for them on Monday.
Maybe you should send that to this on campus.
That's an option too. All right, good work today, folks.